Hello YouTubers. Well, I've started building another CNC mill project, and this is like my fourth or fifth one. And I haven't really done a good job of documenting any of the previous ones, so I thought I'd start documenting this one a little better, so I'll have some video and some stuff to put on the web about how I built it and how well it works and all. I've still got the old woodpile CNC over here in my workshop, and I may end up stealing some parts off of it because hopefully the new one is going to replace it. The new one hopefully will be better, stronger, faster, more accurate, all that good stuff. And I can get rid of the old wood pile, and so I won't mind stealing some parts off of it, maybe some motors and some other stuff. Controllers can go into this one. But I thought I'd document this one a little better since I just went and built the wood pile without really documenting much. And people are always asking me, you know, for dimensions and how it works and what kind of motors I'm using, what kind of controllers I'm using, yada, yada, yada. So we'll start out here. I just got started on this. I've got a little bit of work done on it. The frame is out of 80/20. It's the 1.5 inch by 1.5 inch T-slot 80/20. I lucked into a bunch of this 80/20 stuff about a year ago, maybe a little over a year ago, at a going out of business sale for a bike shop. They used it for frames for working on motorcycles, basically. And you know, I got a ton of this stuff dirt cheap, and it's been sitting around. I've used it on a couple of little projects, but this is going to be the first big project that I've built out of 80/20. So I got the frame, the lower frame here built out of it. It's going to be 3 feet by 2 feet this way. Now it runs a little long out here. I'll mount the motor for this axis out here just to keep it out of the way. Also, I had some 3 foot long 5/8 inch rail, linear rail. I had 2 pieces of that, and I had a whole bunch of these linear bearings. Oh, they're so smooth. I love it. So smooth. I had a whole bunch of these. Came out of another going out of business sale. So I put them together. The only thing I actually had to buy special, because, you know, I already had all this other stuff, was these blocks here for holding the rails. But they are pretty darn cheap, especially since I buy them off of eBay used. And I knew they're pretty expensive, but cheap, used, they're cheap. So this is going to be the x-axis, and a lot of people give me grief, tell me I got my axes backwards. They say this should be the y-axis, and the x-axis should go that way. Well, I spent 25 years working, you know, in an industry with CNC machinery that did it this way. With the x-axis was the long axis, the y-axis was the short axis, and it carried the spindle. So I'm used to thinking in those terms when I'm, you know, designing stuff, how stuff should be milled. So that's why I do it. So, you know, you could make your axes any way you want, but mine is, the long axis is going to be the X, and the shorter axis that's carrying the spindle is going to be the Y, and what's moving the spindle up and down is going to be the Z. And that's the way my machines all work, and that works for me. Your mileage may vary. So getting a good start on it here. Got the frame put together. Took no time at all. This went together like, I don't know, less than an hour. So I love working with 80/20. They advertise it as, you know, the industrial erector set, and really it is. You can build anything with this stuff, and I just love working with it. So I'll you know, show you progress from time to time as it goes. This axis is pretty much done except for the lead screw, nut, and motor. Well, the screw and nut are on order. They haven't arrived yet. It may be a month before they get here, unfortunately. But I'm not going to stop building. I'm going to keep building and add them on once they get here. And so the next step is I'm going to start building the frame that's going to hold the y-axis, and I'll show you that when it's done. Okay, just for fun, I've attached a wood platform to the bearings here. Oh, it's so smooth. So smooth. I've got just under 2 feet of travel, side to side. Now this wood platform is temporary. Of course, you know, I say that. It may be temporary for years, but what I would eventually like to do is get an extruded aluminum T-slot table on there, or some sort of aluminum T-slot table on there. But for now, this is just to make sure I've got everything aligned right, so it moves nice and easy and smooth, doesn't bind up at either end. Just push it along with just one finger. Nice. All right. Onward. All right, now I've added the gantry that's going to hold the Y. It's going to go this way, Y-axis, and the Z-axis is going to go up and down. Again, it's just 3 pieces of 80-20 bolted together and bolted on the existing frame down there. I may add some gussets just to. I mean, it's really sturdy just as it is. It just looks a little spindly to me, so I may add some gussets to it to strengthen it up, just so it doesn't twist or wobble under cutting forces. We're going to use this mainly for cutting wood, so the forces won't be too bad, but still, I think I'll add some gussets to it. Some diagonals. Diagonals are never a bad thing. I also need to add some legs on this thing. So, and let's see. Oh, there it is over there. I have 2 more of these rails here, 2 feet long. So the 2 of them will be mounted up here for the Y-axis to move back and forth on. I'm waiting on more of these SB10 rail blocks to show up. I have ordered them, found some on eBay cheap, and they're coming. If you want some of these rail blocks, Thompson makes them. And buy them new from Thompson, they're expensive. Shop eBay. Feel free to shop eBay. I've already bought all the cheap ones off there, but I'm sure there'll be more soon. So when they arrive, I'll be able to bolt together, or start bolting together the Y-axis up here. Well, I got a pleasant surprise in the mail yesterday. Yeah, the lead screw and nut and mounting hardware, bearings and stuff all arrived yesterday. I'm just sort of mocking up the position here. Nothing's bolted down yet. Trying to figure out how I'm going to mount it. But I was very pleasantly surprised by that, because the expected delivery date was still a month away. I figured it was coming at me on a slow boat from China. But there must have had one in a warehouse here on this side of the ocean, because it came relatively quickly. Looks great. Looks nice. So smooth too. Oh, yeah. Can't wait to get this mounted. I might be able to get that done today. I was going to work on some other aspects of this, but maybe I'll mount the X-axis screw instead. Alright, I'll show you what it looks like when it's done. So, I got the screw mounted. The X-axis works. Works great! Works great, very smooth. Need to get the motor mounted on there. That'll happen eventually. Still need to put legs on it. And I've taken the gantry for the Y-axis off temporarily while I worked on this. I'm going to put it on, but I'm going to move it. I'm going to move where it was, because I made a slight mistake. I centered it. I made the mistake of centered on the travel of the X-axis, but it actually needs to be offset, because the router is going to hang off of one side of it, and to get, you know, full range of motion, I need to offset it by that. So I'll redo it. But fortunately, with the 80-20, that's as easy as drilling 2 new holes in the sides and bolting it back on in the new position. So that's super easy. It's very forgiving if you make a mistake. I love it. because I'm not always perfect. That's just a rumor I spread. Yeah, making progress. Love it. All right, here's what I'm going to use for the Z-axis. It's this Velmax Inc. 3-inch travel platform. I don't know much about it other than I got 2 of them when a company I worked for a long time ago closed up shop, and we got rid of a lot of equipment, and you know, these wind up coming to me. I got one on my old woodpile CNC in there, and you know, it works pretty well. Now it says it's meant for 3 inches of travel, but I took the bottom plate off, and I think I can probably get 3.5 to 4 out of it without, you know, any issues. Not as much travel as I'd like, but I never have as much travel as I like on any axis of the machines. But this works pretty well. It's pretty smooth. The screw is really, really fine, so it takes a lot of rotations to get a little bit of movement out of it. And mounted on top of it, I've got this rotozip, and I'm going to use that initially for my spindle drive, and I'll just put a router bit in it because I'm going to be mostly cutting wood with it. And it's basically what I've got on the woodpile CNC now is an old rotozip, and they work pretty well, and they're not too hard to mount on here. So we'll give that a try and see how well it works. Here's a close-up of the nameplate on the slide. And here's the plate I took off the bottom of it that would have, let me get it over here in the shade, where this would have stopped the travel after 3 inches, but I took this off so I can get another 1/2 to inch of travel out of it. So if you can find any of these, they're a neat solution for a Z-axis because it's everything you need in one ready-to-go package, basically. You just have to bolt your spindle to it and you're good to go. So maybe you can find some of these on eBay if you're interested. Okay, I've been working on the gantry here that holds the Y and the Z axis, and it's coming along nicely. It's basically the same setup as the X axis. I've got these 5/8 inch circular rails here, and blocks to hold the rails, and linear bearings to ride on the rails. And oh, it's so smooth. It is so smooth. I haven't even oiled this yet. It's so smooth. Oh, I need to put a little oil on it. So it's coming along. It's, like I said, basically the same as the X-axis, just on a slightly smaller scale. Not as long, not as wide. I'm waiting on the screw and the nut. Those should be here hopefully in the next week or so. Maybe they'll arrive early like the X-axis one did and surprise me. That would be nice. So when that's on here, I'll be able to, when that arrives, I'll be able to mount the screw and the nut and bolt it to this, and I'll be able to mount the motor, and I'll be able to mount the Z-axis on here, and then this can get mounted on the X-axis, and most of the mechanical work on the machine will be done. There'll be a lot of wiring that needs to be done. It'll need home and limit switches, and of course I'll need to wire up all the motors to the controller and put in an e-stop switch, and there's a lot of wiring to be done, but at least most of the mechanical work will be done. So just waiting on some parts to arrive. Can't go much further, but oh, I love that. That is so smooth. Oh, and the observant among you may have noticed that the legs on this gantry are longer than they were in the earlier part of the video where I had the machine partly assembled. The shorter legs would have been fine if I was working down on the deck routing stuff or something, which, you know, I'll probably do a lot of. But if I was going to run my turntable on here, put the turntable on the deck, and then work on stuff on it, there wouldn't have been enough room, because I only have about 3.5, 4 inches of travel on the Z-axis. There wouldn't have been enough room to get the turntable in there. So I put these longer legs on the gantry and reassembled it. So that should give me room to run the turntable if I want. I just wanted to explain why the legs on the gantry got longer. All right, I've got the motor mounted on the X-axis. And it was pretty easy. I got a piece of heavy aluminum angle here. This is a big motor. It's probably, I mean, compared to my hand, and I got big hands. This is a big motor. It's a NEMA frame 37, but it's actually such an old motor that I think it's pre-NEMA standard, but the whole pattern is NEMA 37 anyway. It's a big-ass motor, okay? Probably overkill for this, but hey, I've got 3 of them. I might as well use them rather than buy new motors. And, you know, I won't have to worry about this thing being underpowered with these motors on here. But a big piece of aluminum angle down here, which is bolted up into the 80/20 channel here on the bottom. And I cut slots in here so I could move the motor up and down to get it to align vertically. And I could slide it back and forth in the slot to get it aligned horizontally, and then tighten it all down. And got the shaft coupler on here, and it is really just a beautiful alignment. Much better than I could achieve on my old woodpile CNC. So this is really great. I'm not really seeing any compression or extension in that coupler as I rotate the motor. So I just love working with 80/20. It makes everything so easy to get accomplished. So okay, there's one more job done. Still waiting on the screw for the Y-axis. When that arrives, I can mount the motor in a similar way. And then I'll have the Y-axis done. So making progress, a little bit every day. So while I've been waiting for the screw to arrive for the Y-axis, I've been working on home and limit switches for the X-axis. So there's the home switch. It's riding up against the linear bearing down there. Hope that click is coming through. And then if we blow past the home switch, there's the limit switch right there that'll shut the machine down before it plows into the block holding the round rail. So I think that's going to work pretty well. So this is on the front of the machine, and I'll put a limit switch on the back of the machine because I really only need a home switch on one side of each axis. I don't need 2 home switches, but I need 2 limit switches. So let me get to work on that. And here's the limit switch on the back end. I don't know if that click is coming through. Now I really only need 1 home switch per axis, but I need a limit switch at either end of both axes. So there's a limit switch on the back end. So limit switches, home switches, making progress. And good news, the screw and nut for the Y-axis just arrived. So I'll be able to start working on that soon. Well, good news, the screw for the Y-axis arrived, and mounting it was pretty darn quick and easy. I got about 15.5 inches of travel. It'll probably be a little less than that after I put the limit switches on it. You know, it's not as much as I would like to have, but you know, there's no such thing as a machine with as much travel as you'd like to have. I think there's a lot I can do with this machine with the amount of travel I've got. So, very smooth. So I need to look at getting home and limit switches on this axis, and then mount it on the X-axis. Then it's on to the Ooh, I hope you can hear me over the wind. There's a storm coming. So I kind of got this done in just the nick of time. I think I'm probably done for today. I'll have to put everything away before it starts raining. But I got the motor mounted, and I got limit switches on both sides and the home switch over here. Click, click, click. The home switch, and then the limit switch. In case we blow past the home switch. Right there. Okay. So that's pretty darn good. And, you know, got the same thing over here on the other side. I got a limit switch so that we don't crash into the support blocks for the linear rail. And got the motor mounted. And again, it's another good alignment. I just love working with 80/20. It makes it so easy to do just about anything you want to do. So this axis is almost done. Actually, it is pretty much done. I just need to mount it on the x-axis, and I need to mount the z-axis on it then and tram it up. The wiring still needs to be done, but we're making good progress. But like I said, there's a storm coming, rain's coming, wind's coming. I think I need to button everything up for the day and maybe, just maybe, be able to work on this tomorrow if the rain moves out in time. So, more to come. Alright, we're changing gears a little bit here. The mechanical part of the build is pretty close to done. There's not a whole lot left to do mechanically. So I've switched over to the electronics. And I've got this big box here with a couple of power outlets up on top. And this is something that was salvaged from a big CNC industrial machine. Ran some of the electronics on it. I've got it in. It was all relays and stuff, old equipment. And I've started rewiring it for my own use. I got some outlets in here. They're going to be switched over here. So, and I'll put the motor drive and some other stuff in here. We'll plug into that. Power supplies, motor drive, so on. We'll plug into that, and that'll be switched. Also, these outlets here are switched. They're going to go on and off with the switch over here. Now, these outlets up here are a little different. One's going to drive the spindle, and one's going to drive the vacuum eventually. Maybe not all immediately, but that's my plan down the road is the vacuum and the spindle are going to be under computer control for a change. Up till now, I've never done that. I've had to manually turn them on before I start the cycle. So in the future, it's all going to be under computer control. My one concern is this vacuum line may just drive another relay somewhere, because I think the vacuum is probably going to have to be on another circuit. Otherwise, we're going to start blowing circuit breakers. If I've got the spindle and all of the drive and everything else on, and then vacuum too, I think we're going to draw more than the circuit breaker can handle. The vacuum draws a lot of power. Anyway, so I'm working on it. I got the box pretty much all wired up so far. I just drilled a couple holes, big circular holes in here. I'm going to put a couple fans in it. One's going to blow in, one's going to blow the warm air out. I'll put a filter over the one that's blowing in. And I will mount the electronics in here, the power supply and the drive controller. Up till now, over here on the woodpile CNC, that was just mounted on the back of the thing, you know. I just had it mounted on the back, and I want to put it in a proper enclosure, keep dust and swarf off of it, and just make it a little more professional looking. And there's going to be some other stuff in there. This controller over here, even though it works great, was designed to be driven by a parallel port. And, you know, I have some old computers with parallel ports, and I used them to drive this for a long time. But, you know, it's 2020, and computers with parallel ports are getting as rare as hen's teeth. And, you know, the ones I've got aren't going to run forever. They're pretty old. So I've got a interface box now that it's USB, and it breaks out a whole bunch of I/O pins that can be programmed to do all kinds of different things. And what I've done is, and I'll show you that in another segment, because out of view right now, and I've got to take the cover off and everything for you to see it. What I've done is I've broken out the pins, the various pins for the parallel port over here. And what I'm doing now is I'm driving this unit from a Windows 10 computer through the USB box, through the breakout box, to the parallel port. So, and it works pretty darn well. So, you know, that's the way of the future as far as I'm concerned. Now, I could just replace this with a USB unit and get rid of the box in the middle, but, you know, it works. I've got it. Why spend extra money? You know, if this thing ever dies, which I'm sure it will someday, I'm on my second one because I burned the first one out. But, you know, I'll replace it with a more modern unit. But for now, it works. You know, I'm going to put this in the enclosure back there. I'm going to neaten up the wiring a lot because this is a mess. And, you know, mount it probably on the side of the workbench out of the way and just plug stuff into it. And it'll be a lot cleaner, a lot more professional, and everything will be out of the way. Anyway, that's the plan. This is going to get mounted in a box. And the wiring's going to get all neatened up, and everything's going to be a lot more professional, a lot neater, and hopefully it will all work fantastically. I'm pretty confident. It's not my first rodeo with building a CNC machine, so hey, if this mess works, the new one should work fantastic. So anyway, making some more progress on the electronics, and just about ready to start stripping the old wood pile for parts. I did, yesterday I spent the day doing 2 last projects on it, just to get them out of the way, and then, you know, maybe the next few days I will start stripping it for parts. And just... Okay, so I've started robbing parts off of the old wood pile in there, wood pile CNC. So here's the driver over here, here's the power supply for it. This is the unit I was talking about in the last segment. This is a USB interface over here, and it breaks out a lot of stuff around here. And right now, it's got outputs for 4 axes, you know, step and direction, and it's got inputs for switches. It's got all kinds of stuff. And what I did was I bought this, and I had actually, it's an RS-232 breakout board right here, but it works for parallel ports too. And what I did was I wired the 3 step and direction axes signals in to the appropriate pins on this, and also I have the e-stop wired into it, and a couple other things wired into it. And I ran a parallel cable from here down to here. And that's how I ran this thing using the Windows 10 computer instead of the old XP computer with the parallel port. And it worked pretty well. So what I need to do is I need to fit both of these things in this big box here. I also need to get the fans in. I need to wire everything up. I was powering this unit with a wall wart here, but I think I could steal 24 volts from this and get rid of the wall wart. I should also have enough 24 volts of capacity to run the fans too. So really, I got a 4 outlet plug in here, but I probably only have to plug one thing in, and that's just going to be this power supply right here. So that's good. And I've got 3 holes left in the top. One I ran the main power cord through, but I've got the 3 other holes in the top. I can run the cables for the 3 axes and all of the limit and home switches through there into the unit, and also e-stop switch. Should be plenty of, you know, if I need more holes, I can just punch another hole in it, no big deal. But I got to get all this mounted in here. So that's my next big job, getting all the electronics mounted. And disassembling the old wood pile, getting it off my workbench so I can put the new machine, which is in pieces scattered around here, together up on the bench and start getting it together. Oh, got my work cut out for me. Keep watching. Okay, I think I've got everything pretty well mocked up the way I want it. There's the USB interface board up there, mounted on the door. And down in here is the power supply and the driver board. And the high voltage wiring. So everything's, you know, I got the fans in, at least temporarily. They're probably going to have to come out to get wired, get longer wires put on them. But everything looks pretty good. I think I can make this work as an airplane flies over. Why do airplanes always fly over when I start trying to make a video? Anyway, I think I can make this setup work. So I'm going to go with this for now. And just a whole lot of wiring left to do. And routing cables and tying them down and all that good stuff. But yeah, it's looking good. I think I can make this work. So making progress. Well, here we go. The new machine has moved indoors. The old wood pile has been disassembled, stripped for everything useful, and disposed of. So the new machine is coming together. As you can see, I've got the Y-axis mounted on top of the X-axis. I got the gussets on. That's really, really rigid with the gussets on. It's just solid. I love it. So I got to mount the Z-axis and the Z-axis motor and do a few other things. Then, let's see, I've got some more wiring to do in the control box before we can have a motion test. But it's really coming along. It's looking pretty darn good. You know, hopefully not much longer. We can have a motion test. All right, the Z-axis is done. Got the motor mounted on it. Got the rotozip mounted on it. I even have a bit in the rotozip. So, takes a lot of rotations to get a little bit of movement out of the Z-axis, but there you can see it going. So basically, with the exception of, I want to modify the legs. I've just got some legs made of carriage bolts on it right now. I want to modify those and make some legs with hockey pucks on the end, because I really love hockey pucks for making legs. They absorb vibration and they're just anti-skid, and they're great. So I'll do that. But basically, except for the legs, the mechanical build is done. So I've got to finish up the wiring and route a bunch of cables, and then we're going to have a motion test. So getting there. Yeah, making progress. Love it. All right, we are up and running. Power supply's on. Nice green light there. Fans are running, both of them. Driver board has power. USB interface board has power. And I didn't let the magic smoke out. Yay! It's all working. Hallelujah. All I gotta do is plug the motors in, and we could be able to have a motion test pretty soon. Maybe tomorrow. It's getting late today, but I made some good progress. I'm very happy with this. It works. More later. Okay, well, the wiring is not turning out quite as neat as I would hoped I could have made it, but I'll clean it up some more. I've got everything pretty much hooked up except for the home and limit switches. Everything else is wired in, and I'm about ready to do some motion testing and some motor tuning. Hopefully I won't let the magic smoke out of anything, but I think it's all good. There's a lot of extra wires around. These go to limit switches and stuff. The other ends aren't connected to anything yet, so I just want to make sure that I can actually make it move and tune it so that the axes move nice and smooth. Then I'll sit down and start on the home and limit switch wiring. So motor tuning next, and we'll see how it goes. Okay, I've spent about the last hour and a half in Mach 3 over here. Someday I need to upgrade to Mach 4, but for now Mach 3 does everything I need. Anyway, I've spent about the last hour and a half in here doing some motor tuning and some motion testing. And the X and Y axes, they were pretty straightforward, pretty easy to set up. There's the Y axis. Moves nice. And then here's the X axis. I made sure that the E-stop button was wired in, working, and within reach before I started doing this, just in case anything ran away on me. The Z-axis is where I spent the bulk of my time. The X and Y, like I said, were pretty straightforward. Once I got one of them working, because they have the same screw, same pitch, everything, I just copied the settings over to the other and it worked. But the Z-axis gave me some trouble, because it has a very different screw on it. It 20 turns to the inch on that screw on the Z-axis, whereas you've got a 5mm pitch or 5 millimeters with every turn on the X and Y axes. So getting this tuned so it was running smooth and not skipping steps, that took me quite a while. But now it's working. So all three axes are working. Oh, and I have the spindle wired in too. It's under computer control. Sweet! Never had that before. I've always had to start it manually, and sometimes I'd forget. That's bad. Start a cut without the spindle turning. So I'm making good progress on it, and I'll show you why I have my axes laid out the way I do. With this being the X, and that being the Y, and that being the Z. If you look at the keypad on my computer, when it's sitting in front of the machine like this, you know, if you think about your coordinate system, you know, X, right, left, Y, up, down, you know, so you've got, it moves in the same direction as the buttons. You know, if I push this button up here, it goes that way. I push the down button, it goes that way. And of course, you got page up and page down for the Z-axis. So, you know, you've got your coordinate system here, and this is just the way I think about things. X, right and left, Y, up and down, and Z, and I can sit here and I can visualize cuts with everything laid out like this. So that's what works for me. You know, you do it your way. This is what works for me. But anyway, I am making really, really good progress. It's not going to be long before chips are flying. My goodness, it's been a productive day. There's a lot of wiring still to be done for the switches, and I still need to mount switches on the Z-axis. I may just mount a home switch on it. It moves so slowly, I'm not too afraid of it to running away to one limit or the other. But it definitely needs a home switch. I need to hook up the home and limit switches on the other two axes and wire them into the control box over there. But on the whole, things are going good. Oh, but I think my next project is going to be to finally make the feet for it. I got a whole box of hockey pucks in the mail the other day, so I can make my beloved hockey puck feet for this thing and level it up good. So that may be the next project. But wow, the chips will be flying soon. Things are coming along. I love it. So here's one of the hockey puck feet I've been talking about. Just got a carriage bolt that I've countersunk into the bottom of it, and got a nut and a washer on this side. And then this makes a really good foot. I use this on optical equipment all the time, telescopes especially, tripods, whatnot. It's vibration absorbing, and it's non-skid. It makes a really great foot. So I'm gonna put feet like this on each of the 4 corners of the machine. So I just made one. I've got 3 more hockey pucks over here already countersunk. So I just got to make 3 more feet and mount them. And that'll be one more job done. Well, there she sits on her 4 hockey puck feet. One more job done. And I think that's all for today. I think I'm going to wrap it up for now and pick up where I left off in the future. Well, I took a little bit of a break from the wiring to do one more little mechanical job. I had this extruded aluminum T-slot. It's from a much smaller machine, but I went ahead and mounted it in the middle of the wood platform of the X-axis here. So that should let me clamp things down fairly easily for cutting. My plan eventually is to replace this hunk of plywood with an aluminum plate. That may be a little ways down the road, but eventually I want to do that because the wood won't warp and twist with changes in humidity, or the wood will warp and twist with changes in humidity, but the aluminum won't. But for now, I'm gonna run it with the wood, and I've got the T-slot bolted on here now, so I can clamp stuff down fairly easily. Okay, back to the wiring now. All right, today's a big day. Today we're making chips. Today the machine is basically done. I've got a little platform I've built here. I'm going to be mostly using this with the turntable, I think. But to do some basic testing on it, I've built a little wooden platform and got it bolted down with T-nuts and washers here, and raised up the wood here enough that I can cut some circles in it and measure them. And what I'm looking for here is the diameter of the circle on the x-axis, diameter on the y-axis, and whether there's any overlap that would indicate I've got some backlash. So I've been cutting circles and playing around with it, and I'm going to cut another one. I've got the computer up. This is the Windows 10 computer over here, and we're running through all the electronics in the box. The XP computer's underneath it. It's probably going to be retired. So we're ready to do another cut, and I'll show you what it looks like. And let me get my hearing protection on, because it's kind of loud, especially once I start the vacuum. I don't have the vacuum attachment on it yet, so I'll just hand hold the vacuum nozzle to collect the dust. But you'll see the router come on, you'll see it make the cut, and I'll be hand holding the vacuum and starting it manually. Anyway, here we go. Starting now. Okay, hearing protection off. Let me move this over where I can measure it. Sorry, I keep kicking the tripod. That's probably very annoying to those watching. Alright. About 3 thousandths oversized, which, cutting wood, I'm not too worried about, you know. And that axis we're right on. I mean, that could be just an issue with the grain tearing out more going one way than another. 3/1000ths on wood I'm not too worried about. I'll need to cut some aluminum or something to get a better measurement, but that is really good. And let me get the camera off the tripod and show you what the circle looks like. I mean, there's none of the overlap that you would expect if there was a backlash problem, which I've seen on some of my other homemade machines before, where there was a lot of backlash and I had to adjust out the backlash. That is a perfect circle. Absolutely perfect circle. Yeah, I wasn't expecting a lot of backlash with these ball nuts, and there really doesn't appear to be. It's not measurable cutting wood anyway. So the machine is working really good. It's this is a great day. After all this work, it's finally done. And it's ready to start doing actual projects. So I'm a very happy camper. I've got my new machine finally done, finally ready for some production. The new computer, the new electronics, and the new hardware. Everything's working. And I hope this video encourages other people out there to build their own machines. It's really pretty simple. It's like building with an erector set, and you can order all this stuff off of Amazon and eBay and just bolt it together. You know, it's super simple and it works. So anyway, thanks for watching. Feel free to ask questions in the comments section, and I may post some future videos of various projects being cut on this machine. And so watch for those. Anyway, thanks for watching, and I'll see you in the future. Bye.